So hello guys, welcome back to a new video, and in this video we are going to study multidimensional arrays. Now, what are multidimensional arrays? Multidimensional arrays are the arrays which have multiple dimensions. Now, not talking about the multiverse of multidimensions. Yeah, I could not think of anything else. But stopping to this, there are many questions. What is multidimensional array? Why do we use multidimensional array? Can't we use array, or we can say unidimensional array instead of multidimensional array? But I'm going to answer all these questions and give you some extra tips, or we can say I will guide you through the journey of multidimensional arrays. So stay tuned and tighten your seatbelts because this is going to be interesting.
Here we are on the complete screen. So the first question which you asked, or I can assume that you asked, okay, was that what are multidimensional arrays? So if I put it simply, multidimensional arrays are nothing but an array of arrays. Now, what do I mean by that? The thing I mean by that can be shown physically, or we can say like this. Hey, okay. So if you see this, let me zoom in a little bit, okay. These are multidimensional arrays, okay. I have picked this image from a site called edufioba.com. You can see it here. Anyways, okay, so this is a two-dimensional array and this is a three-dimensional array, okay. The point is that both are multidimensional arrays, okay. Now, if we want to see this more clearly, this is a multidimensional array, which is a two-dimensional array if we talk about it more specifically. So, first of all, we will talk about two-dimensional arrays. So, this is a two-dimensional array. Now, you can see what I meant. Sorry, but my drawing is not that good, okay. So, you have to take things out of this only. So, this is an array of array. If you closely look at this part is an array of three elements. Look closely, okay. Here it is, 1, 2, 3. And if we say that these three elements are what? One element here is a specific array, okay, is another array. Here it is an array in one element of an array, and that was I talked about. Sorry, that was something I was talking about. That a multidimensional array is nothing but a array of arrays. So here we have an array of arrays, okay. Now if we take this part and move it a little bit up, okay, then we take this part and move it here, okay, and sorry, and then we take this line and make it clear from here, okay. So here you can see it is a little bit similar to this, okay. Here we have 4 columns and 3 rows, and here we have 3 columns and 3 rows, okay. So this is similar, and that's how we represent it. Now this is the x-axis and this is the y-axis, and if we add a z-axis, then what do we get? We get a three-dimensional array, okay. This is the representation of 2D array, and if we add a z-axis here also, then we get a three-dimensional array. Now as we have seen here that this is how a two-dimensional array looks like. Now how do we store data in a two-dimensional array, and how do we make a two-dimensional array in the first place? Okay, so let's see this. Here we will generate a comment which will say 2D array. Okay. Oh, 2D array. Okay. Now here we have the syntax. Okay. What did we do if we have to instantiate or just say declare uh, uh, a unidimensional array? Okay. We used to do it like this. If we have any data type in it, we will say this ARR, and here we have the declaration. Now just a little bit different syntax is used in the case of two-dimensional arrays. Okay, what do we do here is we add one square bracket more, and as you can see that this int array is in this array. Okay, so here you can see the connection. Okay, this array, this much part is in this, and this is something which we are calling ARR, which is our array, or more specifically it is our two-dimensional array. And if we say that ARR equals to, here we can assign also values. Okay, so let us say we have 3 rows and 3 columns like this one we studied just now. Okay, sorry, we'll do it like this, equal to new int, and yeah, here we will say 3, here also we will say 3, and here we have a semicolon, and now our array is ready to store data. Okay, so how do we store it? What is the matrix there? How can we store data in this? Now most of you, and if I say that all of you have studied some common classes like 5th, 4th, so all of you would be able to make a table, which we can also see here. This is a tabular format. Okay, so now in this tabular format, as you can see here, we have a column and here we have a row. Okay, so here the columns are 1, 2, 3, and rows are also 1, 2, 3. Previously I counted it wrong. Okay, but here we have 3 columns and 3 rows, just like what array we have. And here we can instantiate the data in the array. Okay, so here we have row 0, and why we are saying 0? Because the indexing of an array starts from 0. We all know that. Okay, and here we have the column number 0 because of the same reason. Now this 0 and 0, this is row number and this is the column number. Okay, so this is also 0 and this is also 0, so we have an ARR 0, 0. So if we say that we want to assign some value, we write here 0 and again 0. Oh, we have to assign some value. Let us say 2. Okay, the value is 2 here, and here we can move like this. Okay, this is a tabular structure. Okay, so if I say that 0, 1, we move it a little bit forward. And how forward? We are taking the row number 0 and the column number 1. Okay, so we assign the value here also. We are assigning common values, let us say. Okay, we are going to Now let me copy this. Okay, control plus D, control plus D, control plus D. Now 3 into 3. How many elements do we have here in total? 3 into 3 will be 9. Okay, common maths. 1, 2, 3, 4, 5, 6. We need 3 more. 5, 6. Okay, here we have 3 more. Now here we will have 2. Now from here we will have 1, 1 and 1. Now from here again we will have here 0, here 1 and here 2. Here again we will have 2, 2, 2, 2, 1 and here 0. And I think it is pretty clear to you now. Okay, you can see where it is going. Now if we click on Control plus S and we run this, what will happen? As you can see, nothing happened, but it just simply stored the data. Now how do we know that the data is stored? Let's see. We will apply a for loop. Okay, let us instantiate these two, or we can say declare. Okay, int I comma j. Okay, for I equals to 0, I less than ARR, not length. Okay, and here we say I plus plus, and here we have for j equals to 0, j is less than ARR, ARR dot length. Then we say j plus plus. Okay, and hence we print here what? We print here ARR, I and j. Okay, and then we run this. Here we have this. But to be more clear, let's do it like this. And outside of for loop, here we have out. Or let us add a space also here for more convenience. Okay, so here we have the representation we wanted. Now you can see what just happened here. Okay, here we considered two variables I and j. Here we have a for loop I equals to 0, and it goes from I equals to 0 till I less than ARR dot length. Now what is the length of ARR here? It is 3. Now if it is less than 3, then in int data type it must be 2. It must be going till 2, 0, 1, 2, and that's the same case in j. Now if we see that we have here ARR, I and j. For the value of I as 0, here we have j equals to 0, then this loop will run, and then we will have the value of j as 1. Again it is iterated, then it will be 2. So for I equals to 0, we have j equals to 0, j equals to 1, and then j equals to 2. And same for I equals to 1, then same for I equals to 2. And here you can see what I'm trying to explain, okay, where this is going. So this was simply 2D arrays, okay. Now what if we talk about 3D arrays, which we will, but let's move out of the computer screen to study that. Let me comment this out first, okay. Let us move out of the computer screen.
Oh. So as we have studied two-dimensional arrays, now it's time to study three-dimensional arrays. Now, first of all, how do we visualize a three-dimensional array? We can visualize it as a 3 by 3 by 3 cube. Okay. So, how can I say that we can visualize a three-dimensional array like a 3 by 3 by 3 cube? Let me show you. Assume that this part, you can see this blue part, is a unidimensional array. Okay. And we say that in one element, this is one element of this array. Okay. Sorry. We are not talking about this unidimensional array because this is a three-dimensional array. But for this instance, let us assume that this is a unidimensional array, and in one element here we have a two-dimensional array. Now, how can I say that this is a two-dimensional array? Here we go. This is a two-dimensional array as we have studied just now. Okay. So this is the one dimension, this is the two dimension. Y-axis, x-axis. Okay. And here we can see this, and we can also see this. So here you can see that starting from one array, in each element we have a two-dimensional array, and then in the two-dimensional array we have several other elements. And if we talk about the data stored in this, we have a common data like we have in unidimensional arrays and 2D arrays also, and this is common. Okay, the data is going to be common, just one thing will change. As we have seen that in two-dimensional arrays, the data in array, if we say that this is a two-dimensional array, which it is not. Okay, this is a cube, this is neither a one-dimensional array, two-dimensional or three-dimensional, but assume that this is a two-dimensional array. Let us think that this part is invisible, we cannot see this part, we can see just this part. Now if you see that here we have this array. Okay, in this array we have this, this and this. So you can see that one array has three elements, and in those three elements we have more arrays. Okay, and that was what we studied in two-dimensional arrays. Okay, don't forget it. Now we just used it in three-dimensional arrays also. I'm explaining it to you twice because I don't want you to forget it. Okay, I'm using three-dimensional object to explain you it in a better way. Now see it. Okay, I'm explaining it again. This is one-dimensional array. In one element we have these elements. Okay, and these elements, if we follow another approach, that we are not saying that in one element we have two-dimensional array, we say that this is an element, and in this element we have this array, and in this array, if we talk about this array, okay, this is an array, we separate it like that, and in this array we have these three arrays. Okay, and this is the end. Okay, this is the end of the three-dimensional array, and I think it is pretty clear now. So let us come back to the computer screen and see how do we instantiate and declare a 3D array.
To see this more practically. Okay, so here we are back on the computer screen. So as we just discussed the 3D array, now it's time to study it practically. How do we apply it in a program? Now, as we saw in the 2D array, what we are going to do is we are going to copy this and paste it in here, and we will do some changes. Okay, like we will add a square bracket also here, not p, a square bracket. Now you can see that here is the error line, red line, but don't worry, it will be clear. Here we have 3. Now we have a different matrix for this. Okay, we will add different brackets here. Okay, control plus Z. Now let me finish this and then I will tell you something. As you can see it here, now we will have a different matrix. Okay, a 3-dimensional matrix. Till now we had a 2-dimensional matrix and it was a little bit easy to consider this. But now we have a 3-dimensional matrix. So first we will have 0, 0, 0. We will follow the coordinate system, so it is more easy. Okay, are you trying to get what I'm saying? Here we have again the 0, and we will have here 1, and here we will have 2. Here we will give 0. Okay, I know it is a little bit confusing, so let's move to this. It will clear some doubts. If we say that this is the origin, then we say that this is 0, 0, 0. Then we move here. This is 0, 0, 1. And what is 0, 0, 1? Okay, let's not say it 0, 0, 1. We are considering x, y, and z axis. Okay, so we will say that 1, 0, 0. Am I right? Okay, no one is here to respond, so I have to do the response part. Here we have the x-axis. Okay, here it is 0. Here again, this is 0. And this is 2. Now our x-axis is completed. This was only the x-axis. Okay, now we will consider only the y-axis. So for the y-axis we have to make changes here. Okay, we have 0, the 000 is here. Here we will have it as 1. Here it will be like 0. This will be 0. This will be 0. This will be 2. And this will be also 0. Now let us give spaces between these. Okay, otherwise it would be confusing. I know this. It is a little bit confusing for me too. Okay, so there is no shame in this. We covered this much, this part in the x-axis. Now here we have this in the y-axis. We will take it as here 0, and yeah, we will separate this. Now y-axis is also covered. Now we have z axis 1, again 0, come back this part, okay, now 0, now here. Now if we see that our coordinate axis is completed, this is the origin and this is this x axis, this is y axis, and this is z axis. Now I know that if you are not good at math, you would be blaming me or cursing me right now, but sorry, I have to explain it like this, otherwise it would be too hard. Okay, believe me, it would be too hard. Now if we figure out how many elements do we have here, 3 into 3 into 3, which is 3 cubed, which is 27 elements. Okay, and I think that writing and assigning value to all those 37 elements, sorry, not 37, 27 elements would be a little bit harder, and that would also lengthen the video. So right now we have assigned value to the origin part, okay, the so-called x-axis, the so-called y-axis, and the so-called z-axis, and I think this is sufficient. Okay, now we will iterate this also. Okay, we'll see that here it is I, j, and z. Let us take it x, y, and z. Okay, it would make more sense. And here we have x, x, and x. Here we have y, y, and y. Oh, I've bookmarked this. Nothing to worry about. Delete bookmark. Simple. Now you know what? We will apply one more for loop, and that's what interesting here. Okay, 0. Then we have z is less than arr dot length. Then we have z plus plus. Then it is all here. Here we have x, y, and z. Oh, a mess. Such typing sometimes gives us problem, but it is a good practice. Okay, so now we will run this, and I know that most of you will be surprised by the output. And here it is, the output. Java reached end of file while parsing. Okay, and this wasn't the output we were expecting, so we will apply a curly brace here. Oh no, don't want any bookmark. Here you can look, it is looking somewhat like this: 2 2 2 2 0 0 2 0 0, and I think that it might confuse you, but let us see how is it. So okay, look at this closely. If we closely see that what is happening here, the thing which is happening here is that here is the origin. Okay, I'll leave it. It is quite hard to explain you this. Okay, and it is not even worth it if I explain you this physical representation. This was this would not be that helpful. Am I right? Am I right all the times? No, I am not right. We have to study this. I was just joking. Okay, so how did this 0 come here? This is also a question. Now you can see 0 is assigned to each and every place where we have not assigned the value. Now if we see that we have folded this, okay, we cannot see it as a cube, but let us try to see it as a cube. And for seeing it as a cube, we have here 1 2 3, then fold it 1 2 3, and then again fold it 1 2 3. Okay, here we have this, a cube with, what do I say, two sides incomplete. Okay, now here we have assigned the value here, 0 comma 0 comma 0. Now this is the 0 comma 0 comma 0. Now this is one surface. Till now here it is one surface. Here we have this x-axis. Okay, now this is the x-axis, 2 and 2. Here we have assigned the value. Here is the y-axis, 2 and 2. Okay, as you can see, here is the y-axis, x-axis, y-axis. Now if we leave this, okay, this surface is left here, then we have this z-axis. Now you can assume that this is layer, this was the first layer, and this is the second layer which will be put on this. Okay, so this is coming over this too. Okay, this will come over this too, which means that this too is overlapping this too, and this too will overlap this and this too. And here you can see it is the z-axis. Okay, let me draw it. Okay, it will make more sense here. I know that I'm a little bit boring in this, but we have to see this. Okay, and yeah, I'm not boring, don't call me boring. This is a line with single arrow. Okay, now if we say this is our x-axis. Okay, sorry, y-axis. Hey, don't move, don't move. Let us select the thickness. This is the thickness. Then again insert lines. Then here we have another line, and then here we have another line. Oh, don't interfere with this line. So we'll have another line. This is our z-axis. Okay, now if we see that at this z-axis we had a 2 here, a 2 here. Okay, what I'm trying to explain is that, see this is the first layer till this, this and the part beyond this, not beyond this, under this. Okay, we are not studying something beyond science. Okay, this is 2 2 2, and here we have the part under this. This is the first layer. Okay, and this first layer is forming this. Okay, this is the first layer here, then the second layer will come here, and third layer will come here. Okay, now you can see the layer system, and now I think that it is pretty clear, and at this point I can end this video. And why I'm saying that I'm ending this video, because I just discussed 2D array and 3D array, and I said that we will discuss multidimensional arrays. The reason behind this is that we have discussed the two major important, I use the word major and important, so it might be, or we say it must be very important. So these were the two types of arrays which are most important when we talk about multidimensional array. We can make more arrays. Okay, there's no harm in problem in making more arrays, or we can say the arrays with more dimensions. you can take this array, and in one element you can have another array, and you can make a 4D array, 5D array, a 6D array. But if we talk about the application, 2D arrays and 3D arrays are the mostly used multidimensional arrays. Okay, even if you are not using 2D arrays, which is widely used, or we say mostly 2D array is only used, then you would be using 3D array, and you won't be going that far. You won't be using 4D array or 5D array in daily usages. But still, if we have to tell, and I cannot say this, that we have to tell, I have to tell. Let me tell you the syntax of the array also. Okay, now here we are going to define a common common syntax. Okay, we are going to remove this from here, apply a multidimensional comment. Wow, what a comment. Okay, so int here. Now how many dimensions do we want? The number of dimensions we want would be decided by these. What I mean to say that if we want the multi-dimensional array of n dimensions, then we have to write these brackets n times. Okay, these brackets would be written n times, and the number of elements would be decided by the product of these three. Okay, what do I mean by these three? By these three, or we can say the n. Okay, n brackets, the value inside the n brackets, which is here. Okay, we will increase one more bracket. The product of these numbers would give us the exact quantity of elements in the multidimensional array, the total number. Okay, and I think that the rest you can do by your own. Here I have explained you the syntax, but as I am telling you this once again, it won't be used that much. Okay, it can be used in certain programs, but it would not be used at a wide extent. Okay, so still I told you the syntax here, and you can use it wherever you want. And with that said, let's end this video and meet in the next video. Bye bye.
For quite some time now, just to see you again. And I've been counting days to get away.